So in the last episode, we discussed about continuity, and also you learned that a function f of x is said to be continuous at a point c if and only the limit of the function f of x when x approaches c is equal to the value of the function at point c. And now, on the basis of this definition, let's check the continuity of a few of the functions. And in our first example, check the continuity of the function f given by f of x is equal to 5x plus 1 at x is equal to 2. And now, in order to check the continuity of this function f of x at x equal to 2, first of all, let's check whether this function is defined at the given point x equal to 2. And if we put the value of x 2, then you can clearly see that f of x is equal to 5 into 2 plus 1, which is equal to 11. So that means the function f of x is defined at the point x equal to 2. And now let's find the limit of the function f of x at x equal to 2. So the limit x approaches 2, f of x is equal to limit x approaches to 5x plus 1, which is equal to 5 into 2 plus 1, and that is equal to 11. So that means the limit of the function f of x at x is equal to 2 is equal to the value of the function at x equal to 2. And as per the definition of continuous function, if the limit of a function at a point is equal to the value of the function at that point, then that function is said to be a continuous function. So that means function f of x, which is equal to 5x plus 1, is a continuous function at x equal to 2. Let's do one more example. Check the continuity of the function f given by f of x is equal to 5x square plus 1 at x equal to 0. Now in this question, f of x is equal to 5x square plus 1, and we have to check the continuity of this function at the point x equal to 0. And in the previous episode, I already explained to you that a function is said to be continuous at a point if and only the limit at that point is equal to the value of that function at that point. So let's first of all check whether this function is defined at the given point. Now, f of x is equal to 5x square plus 1. So what's the value of f? 0. So let's put the value of x in the equation 5x square plus 1, which is equal to 5 into 0 square plus 1, which is equal to 0 plus 1, and which is equal to 1. Now let's find the limit of the function f of x when the x approaches 0. Now limit x approaches 0, f of x is equal to limit x approaches 0, 5x square plus 1. And now when x approaches 0, then in that case, what will be the value of x square? Now x square is equal to x into x. And if x is close to 0, like 0 0.1, 0 0.01, 0 0.001, or further smaller, and if you multiply that number with itself, it will further become smaller, or we can say more closer to 0, which means when x approaches 0, then x square also approaches 0. So the limit is equal to 5 into 0 plus 1, which is equal to 1. So it's clear that the value of the function f of x at x equal to 0 is equal to 1, and also its limit at x approaches 0 is also equal to 1, and that means the limit of this function at x approaches 0 is equal to the value of the function at x equal to 0. And as per the definition of continuity, if the limit of a function at a point is equal to the value of the function at that point, then that function is a continuous function at that point. So that means f of x equal to 5x square plus 1 is a continuous function at x equal to 0. So let's do one more example. Check the continuity of the function f given by f of x is equal to modulus of x at the point x equal to 0. Now, as per the definition of modulus function, you know it very well that the value of modulus x is equal to minus x if x is less than 0, and modulus of x is equal to x when x is greater than or equal to 0. So, first of all, let's find the value of the function f at the point x equal to 0. And now if x is greater than or equal to 0, then in that case, modulus of x is equal to x. And now since x is equal to 0, so that means the value of the function at 0 or f of 0 is equal to 0. Now let's find the limit of this function, and from the definition of this function, it is clear that this function behaves differently when the value of x is less than 0 and when the value of x is greater than 0. So let's find the value of the left hand limit and the right hand limit. Now the left hand limit of the function f of x when x approaches 0 from the left hand side is equal to limit x approaches 0 negative f of x. And when x is towards the left side of 0, that means it is less than 0. And when x is less than 0, then f of x is equal to minus x. So that means limit x approaches 0, f of x is equal to limit x approaches 0 minus of minus x. And when x approaches 0, then minus x will also approach to 0. So that means the left hand limit when x approaches 0 of minus x is equal to 0. And what will be the right hand limit of this function? Now limit x approaches 0 from the positive side, f of x is equal to, now when x is greater than or equal to 0, then in that case modulus of x or f of x is equal to x. So the right hand limit becomes limit x approaches 0 positive of x, and which is equal to 0. So now here you can see both the left hand limit and the right hand limit are both equal to 0. And also the value of the function f of x at the point 0 is also equal to 0. So that means the value of the function f of x, which is equal to modulus x at x equal to 0, is 0, and also it is equal to the limit of the function modulus of x when x approaches 0. And as per the definition of continuity, if the value of a function at the given point is equal to the limit of the function at that point, then that function is a continuous function. So that means the function f of x, which is equal to modulus of x, is a continuous function at the point x equal to 0.